Bienvenidos nuevamente.
Welcome once again, and we apologize for the delay. We'll now resume with the second part of the tutorial. Let me remind you that we have another parallel activity in room 1.4. We have LAC Peering Forum, which is addressed at all those who wish to participate on issues related to interconnection of networks. You can also check the LACNIC 37 agenda to learn about all the activities that we'll be having in the event in a parallel way.
Now, without further ado, I'll give the floor to the trainers. Go ahead. All right. Now, in just a while, we're going to start with a hands-on activity. And while we wait for people to come, we're going to show you the topology and the links you have to open. Erika, are you in Zoom? Because we posted the links on the website. If you want to follow the lab, you can click on the links that Nico showed earlier. And there you will have the different parts. We're going to show it now on the screen. In the meantime, let's check whether my audio is okay. Maybe a little louder or closer to the mic. Maybe they can fix it from there. Can you hear it better? Could you raise Nico's volume, please? There we are. Well, so that is the website of LACNIC 37, and you have the guidelines to have access to the lab and to register in the group, to join the group. This is the website. As soon as you enter the tutorial link toward a more secure interconnection and peering, there you have the links that we're going to use. The first one here is the link where you are going to book your instance. That will be your first step. As soon as you click on this link, you'll enter this form. That is what Nicolas said, that you had to enter your name and your email. And once you access and you enter that information, you are going to be allowed into your second link, and there you will find the listing of the group. And there you're going to look for your names and identify. Remember that what you need to remember there is your group name. And there you have the listing of all the people who already filled in the form. So each will be assigned to a group, and we're going to tell you what you're going to be using it for. After you register and you validate your group number, you'll find the third link, and there you're going to have access to the passwords of the subgroups. You'll have a number of passwords. So at our lab, you are going to have to connect with a router and an end user. So after you register, look at your group number, and you can enter the third link, and you'll identify your group, starting with group 6, because the first groups is going to be by the trainers. And so after group 6, you'll receive a password where you'll have access to your machine. In the first part, you see the passwords for the routers, and At the bottom of this file that is being created, you'll find the password for customers. What you'll have to put here is the name of the subgroup that you put in the previous link. And after that, in the fourth link, you'll see the step-by-step instructions of what we'll do in the tutorial. So here we have the topology, and there we will have management of this router here and the client. These are the passwords that we'll receive when we enter the data in the Google form. And there in the lower part, you'll find the step-by-step procedures, what to do. And this at the lab, this is going to be your guide, the instructions, and you can cut and paste the steps at the lab. And finally, in order to enter the machines, we're going to have access to the last link. And you see that here in the X that we found in the URL that says grpx. Then we are going to put the number of our group so that each can enter their own instance. I am group 3. So I'm going to click on group 3 and it allows me in. So once you load that information, we'll have access to the interface with the password that we had to administer our router, to configure it, and to manage our client, and to configure it with the passwords that we find here. So now, Michaela and Elisa are going to give a presentation. If you have any questions, we'll walk along the tables. We'll have Santiago and Silvia that will give step-to-step instructions, and then we can go and see if you have any questions to ask personally. Thank you, Erika, for that very detailed information. Michaela and Elisa, could you please come here? The idea is to tell you a bit about the RIPE Atlas project, because that is something that we are using for measurements for research projects. And a problem that we have is that coverage of the probes and the machines, the equipment, are rather scanty in the region against, if we compare it against Europe or the United States. And in some countries, there are almost no deployment. There's almost no deployment of these probes. So the idea is to discuss what they're for, what they are, and I'm going to ask you to show the machines. Let's start with Elisa. Eli, please tell us the Atlas probes that we want to deploy. Hello? Hello, can you hear me? Hello, hello, can you hear me? Hello, can you hear me now? Hello? Well, how are you all? I'm Elisa, and I work as a research and development analyst at LACNIC. And as Guillermo said, I'd like to talk about the RIPE Atlas probes. We want to invite you to support the deployment of our network in the region so that we can conduct measurements and research. And one of the ways is by posting a probe. In this case, I have one. The hardware, it's a small device that gets connected to the internet and a power source, and that's it. It's plug and play. And with this, you'd help deploy the Atlas in the region. Or you can also install it in a server or a virtual machine that you can run around the clock. And just by installing a probe, you're really helping. If you want to measure yourself, or if there's anybody in the region that can do it, so that we may have more measurement points in our region. Thank you, Elisa. Michaela, could you tell us a bit more about RIPE Atlas and especially the anchors that we want to deploy in the region too? How long do I have? Hello, everyone. It's very difficult to speak quickly about this topic because we need to explain many things. But it's a project that depends on the community. So we are looking for people ready to host the probes. We offer a platform for your own measurements, and there are measurements that we do in RIPE and CC of common interest that may also be useful. So Elisa showed you the probes. These are the smallest, but we also have other devices that the platform uses. Those are the anchors. Those are sort of small servers that need more bandwidth. The nice thing about the probe is that you can also install it at home, and that's the other good thing about RIPE Atlas. You can measure connectivity from the end user's home, while the anchors require a much broader bandwidth. So, for instance, you can plug them in companies or data centers. And why should you have an anchor and not a probe? Well, the anchor is an objective of the measurements, and at RIPE NCC, we conduct many measurements using the anchors. So by hosting an anchor, you have the visibility of your network from all over the world, because we have anchors distributed all over. And you don't need to do anything because we do the measurements in RIPE NCC. What else could I add? Thank you. Well, so that is basically the idea, to help with the measurements.
This will also be useful for you to measure things in your own networks and how your network is seen from outside, from other places. Because when you set up a device such as these and register, you have credits, you can carry out your own measurements, and you can use a global Atlas network, which is all over the world, and you can take advantage of that infrastructure. Elisa just showed us the probes by hardware, and these are small boxes that you can set up in your own home or in the office network or wherever. So that's a great advantage. But sometimes it's not so easy to deliver these boxes, because if we send them, they cannot be imported that easily, and we use these events in order to distribute them, but it's not so easy. So there is another solution which are the software probes. Can you tell us, Elisa, what this is all about? So, like I was saying, the software probes, the requirement they have is that they have to be set up in a server that can always be running, because the probe can be used if it's always connected. If you disconnect it, then it cannot be used. So the main requirement is precisely that, a server where this is always connected. And from LACNIC, in order to support you, in addition to the instructions manual that you can request from us, we also started to deploy the software probes. So we wanted to invite you, those of you who are interested in having a probe or in your community, if you wish to participate in a deploy-a-thon. These deploy-a-thons, we already organized a few, and it's very fruitful. And we take advantage of this not only to deploy the probes, but also to share experiences and to conduct the measurements that we would like to do. So tomorrow, Tuesday, Wednesday, and Friday, I will be at LACNIC's booth, which is outside. Those of you who wish to come to the booth, if you can come if you wish to have a probe, and we'll give you a hardware probe or a software probe. The booth has hours in which we'll be there Tuesday afternoon and then Wednesday and Friday, so we look forward to seeing you at the booth. And Michela, where can we find you, and what are your contact details? I will be with Elisa at the booth, at the LACNIC booth, and during those same hours, I will be around here. If you have any questions, please come up, and I will be delighted to clarify any questions that you might have. Thank you. Anything else? Yes, you'd like to take the opportunity of being in Cali where there's no probe connected. So if there is any contact that you have, or even you, please come to the booth to see if we can arrange that while we are at Cali, at the event in Cali. Yes, that would be great. Please contact Elisa, please contact Michela, so that you can get a probe, and maybe we can install one this week. So thank you very much for your participation. So now we'll go right on to the tutorial. I hope you were able to access the links and open the laboratory. Nico, you now have the floor. In Zoom, are you there, Nico? Yes, can you hear me, Guillermo? We can see you.
Ahora sí.
Yes, we can hear you, yes? Yes. And we can see your screen. Are you going to share your screen? I will try to share my screen. I will then go down. So please let me know if you can see my screen with the topology, Guille. Yes, yes, we can see your screen. So going back to what Erica was telling you about earlier today, this morning, in this URL, the last URL you have in the place where I sent you all the links, this part of the URL says GPRX. You replace the X with the number of the group that has been allocated to you. I'm group number 1, so I'll put GRP1. And then I have the topology. This will be the screen that we'll be using for the remaining of the lab. So you, in addition to this screen, The only other thing you might need is a file with the two passwords, the password for the client and the password for the router. And the guide for the practice session that we'll be following step by step. We'll execute this, and you will be doing so in your own devices. I will be asking questions as we go along, which anyone in the room might offer to answer. Otherwise, the members of the panel can just choose someone at random. It's always good to have volunteers to answer the questions. So once we are here on this screen, I will access my client. I click on the client, and automatically you get another label. So the topology is open there at all times. And here in this field where you have password, not passphrase, password, is where you should enter your password. Your password is from the password file. Everything that you see there after the comma, including the equals sign. So in order to access your client, as would be this case, I copy everything that you see after the comma with the group corresponding to my user, my group, which is group number 1. So I look this up, GRP1 hyphen comma, and everything that I see after the comma, including the equal sign, I copy that and I paste it here in the field where you have password, and then click on connect. And then you connect to the client. I'm already connected to the client, and I'm going to do the same. I'm going to connect to the router, and I am now connected to the two devices. And I'll go here and do GRP1 hyphen RTR. I copy everything after the comma, including the equal sign, and I paste it on the password field. I click, and there it is. There is a timeout, and this is 1 hour. If you don't write anything during 1 hour, then you just run out of time. So one for the topology, one for the client, and one for the router. That is all we need in terms of devices and topology for this practice. In addition to that, I have the URL with the guide for the laboratory. This has been published in the GitHub site of LACNOG. You have it after the event. If you want to do the practice again after the event, you have to validate this with a Ford validator and an FRR and a client. And that's the only thing that you have to do. We only haven't explained how to install an FRR router. And we'll explain how this works. It's easy to configure. We use Ubuntu as an OS. Otherwise, any Linux OS you can do. In the case of Ubuntu, apt install FRR, and then you have to edit the configuration file to edit some other things. For example, a PGP, and enable RPKI and some parameters that we'll be sending you so that you can have them. So let us follow the script of the practice session and asking questions as we go along, and also doing some testing. So far, so good, Guillermo? Can you hear me? If anyone has any questions, Erica Vega is here. There, she raised her hand at the back of the room. So if anyone has any questions as to how to access each of the sections mentioned by Nico, please let her know. You raise your hand, and we also identify you and come to assist you. Nico, go ahead. Silvia? Can you hear me? All right. So, did you follow the explanation so far? Yes, we were able to hear you. Thank you, Nico. Go ahead. So, let us now look at the practice session. As Erica was saying, the topology is the following. Each group has these two resources. This router, which has a couple of networks connected, but the one we're interested in are these two connections that connect it to a sort of backbone, and the one that connects it to the client network. So each router, you will see, have several interfaces, but the interfaces we're going to use are the ones that connect it to the client that has been configured, and the one to the backbone, which has also been configured. So what do we have in the backbone that we're interested in? Well, there are three devices that we're interested in. The one is another router, which is a border router. We're going to establish a BGP session with that router, and that border router will be like our router of the traffic exchange point. So all the devices, all the routers of each of the devices that you use will establish a BGP session with this border router. And this border router will be the one that receives from the internet the BGP table, the full BGP table. We're not going to give you the full routing table of the internet prefixes. We're going to just send you some of the prefixes, which are the ones that we'll be using during the lab. In addition to this device in the backbone, we have these other two servers. Each of these has a Fort variable for RPKI. How can I access my router? I put the mouse on top of the router, I click, and the window opens with the access to the router. And to access the client, I stand on the client, I click there, and then I can see the window with the client. I can see that people in the chat are putting some IP addresses. Not all devices have the same IP address. You don't have to use the IP address. Forget the IP address that you have in your devices. To access, just click on top of the router or on top of the client. So we'll do the practice step by step, and as we go along, if we have to clarify an IP address, we'll do so as we go along. So let's go on with the practice. I'm going to go to the script. The first thing that we're going to see is the Fort validator. To see the Fort validator configuration, Santiago, are you around?
If you wish, I can show you the config files, and you can explain the basic things of configuration. We can explain it, the two of us together, right? Yes, what I'll do now is, you don't have access to this. Only the trainers have access to this. So I have access to RPKI1, and I'm going to show you this config file, and with Santiago, we'll explain very quickly the basic configuration of some parameters that you need to take into account in the validator. So let me just, Santiago, could you explain the configuration? Well, basically, the configuration, Fort configuration, is a JSON file, and what you have different sections. We start with Ital. It says each RIR has a file that we need to download so that we can bring the ROAs that have been signed. So we can explain it in further detail later. Then there's a directory where you have all the ROAs. You have the ROA repository. You'll see how we can read them. And for instance, where it says server, that shows the port where the validator will be waiting for the queries by the router so that they will provide the table. And they have different details describing the cycle of that validation with regard to the RIR, so how it's going to bring those ROAs and how they're going to refresh them. So in seconds, when the refreshment is going to occur, 900 seconds, when it's going to make a new attempt, 600, and when will it consider, when will that table expire in 7,200 seconds, that is 2 hours. Then there's a logs format. It is for us to see the evolution of the daemon we are running forward. Then there's an rsync configuration, that is, the ROAs are brought with the rsync protocol, and that is what each validator, Ford, Rotinator, or whatever, will go and search in the ROAD repository, and through rsync, they will take it to their local cache. And then there are some further details that are quite specific, and it is important to the last parameter that says output, because there we will have a CSV file that will enable us to check, to confirm that we really have the table of all the prefixes and all the rows that are valid. That's important because it indicates that the validator is working. So Nico, if you want to explain the host. Yes. Can you hear me? Yes. You might have to raise your volume of the size to magnify it a bit better. Can you hear me well? Yes. Yes. Perfect. So if you can see that well, I'd rather not touch it, because if I change the size, I will have to restart my shared screen. Is it too small? Well, anyway, this is just to show you a little part of the content of the file that Santiago was mentioning in this directory, the // Ford. And here we have the ROAS CCV, that is the file that is generated by the validator after processing the hostel that is downloaded from each of the RIRs. So this will be the information that the routers will be able to receive. Basically, it has the autonomous systems and the prefixes authorized to get originated in the autonomous systems, and what comes after the comma is the mask, the largest mask accepted, or the prefix, the most disaggregated prefix that it accepts. So, for instance, let's take any. What it's saying is that prefix 208, 127, 232, 0/21 will be originated in the autonomous system 396982, and it can be disaggregated down to /24. So any prefix between this /21 and the /24 disaggregated originating in this autonomous system will be valid. And the same applies to each of the entries in that CSU file. So here, if you wish, we can move forward a bit with a practice. And this is what Santiago mentioned. This is what we show in this director of the RPKI validator. Then you have the TL, the hostel files that you download from each RIR, and from there you generate that CSV file that contains all the validated blocks. So this is how we initialize the Ford process in the Ford server and the validator. In our case, in this practice, we install the Ford validator as a service. And if you restart the system, the validator will be restarted with the validation parameters that Santiago showed. And here you see the log of everything that, all the messages that I showed in the validator. That is by the validator side. Going back to topology, we have our RPKI 1 and 2 running with the configuration that we just showed. Now we're going to see the config of another device of the border router. This router you don't have access. Only the trainers have access. But we are going to tell you how we're going to show you how it's configured and some characteristics that this device has. The first thing that we'll do is I have a screen with here you have the border router. It's an FRR, and the command line is very similar or identical to a Cisco operative system, at least. And so to look at the config, you run the command show down, and we go up to the beginning. And let me see. Oh, the buffer is not enough to look at it, but anyway, we have it here in the letter of the practice, and we can look at it here. Basically, as I was telling you, this border route has an Ethernet face that connects it with this interface, and then it has another interface that is basically an interface that you don't see in this topology that connects this border router with another router that would be an ISP router, the router that provides internet transit to our entire lab. It's a router that has a BGP session and our border router will receive the global table. So here we have the BGP session of our border router. Our border router will use the private autonomous system 65,000, and each of your groups will use a private autonomous system too that will be 65,000, and then the group number, your group number. For instance, my border router is group 1, so my autonomous system will be 65,001, and group 25 will have 65,025. That will be your autonomous system. So in this BGP session, in the case of the border router, we have the BGP session. We will only do IPv6. We have a BGP session, an IPv6 session with each of the groups that have been pre-configured in the border route with group 1, group 2, a session with group 3, etc. If you look at your routers, in the routers of each group, you don't have a defined BGP process, but as soon as you do that, and you declare the neighbors and you raise the BGP, as the border router has been configured, you should start seeing the publications in your group router since the border router. So what are you going to send? What is the border router going to send you from the beginning? Well, everything it has. And it will accept you to send everything. So this is what it has applied in the BGP session that we raise from the border route. The other thing that the border router has, it has a BGP session against a router of a transit provider that sends us the global table. What we do is we don't want to put in our lab each of the group routers, all the IPv6 global tables, so we filter. So we filter a roadmap that only allows the border router to enter your BGP table. The only one that will be allowed in will be the routes that meet certain rules, meet certain requirements. So here it will allow certain autonomous system. The 28,000, 28,001, those are the in-house numbers for LACNIC, and these are the ones that we use for testing. RIPE and CC uses these to publish their tests. Is it RIPE or APNIC? I don't remember too well, but I think it's APNIC, right? I don't remember whether it's APNIC. Santiago, do you remember? Maybe we can launch a who is. It's RIPE, yes. So it's two testing autonomous systems used by RIPE. And these autonomous systems that you may remember, Erika explained it in the first session this morning. These are two autonomous systems that we have for testing purposes. We have them assigned to each LACNOG, 64135 and 64136. So in the end, the blocks, the prefixes that will end up passing to the BGP to each of the routers in the groups will be only the prefixes originating in one of these autonomous systems. So that is the border router. What I had to tell you. So far, there's no other configuration for the border router. And we will, for instance, this is just to show that if we do, for instance, let's look at the BGP table. Let's look at one of the blocks corresponding to the autonomous system 64135. That's a block that we'll use throughout the session. 2803 colon 2910 colon 8000 /34. So if you look at this block, 28, 83, 93, etc., 8000/24, this is originated in autonomous system 64135. At least we have a direct connection. 64135 actually is our transit provider. So we are we only see one jump of the autonomous system originated in 64135, and here it provides us all the information about that block. Just a comment, this border router, you see that here this is already configured. You're going to see further details, but it has also configured the validation with the RPKI validator. We'll see this with your routers, but as soon as we enable the RPKI process and we establish the communication with the validator, and we tell the router which is the RPKI validator that we're going to use, and the router brings them, it adds information that usually is not shown when they show information of the prefixes. For instance, information that they give me when implementing. Here you have the RPKA validation status. Usually if I don't have this enabled, we're going to see it in your routers. This information does not appear, but as the border router already has that process validated, it tells you that according to the information received from the validator, this block, the /34, originated in 64135, is valid. That's a status. And because, as Erika said this morning, a ROA was created for this block, telling you that that block is authorized for this autonomous system. So, going on with the practice, what we'll see now is the configuration of the border routers, those corresponding to each of your machines, the routers you have access to. So we access to the routers If you put your password, here I'm inside one of the routers in the machine that corresponds to my equipment. And if you execute a show run and you visualize the configuration of your router, it's going to be similar to what we see here in the practice letter.
So the X will be replaced by the identifier with the group number. In my case, is group number 1. And you will have the interface pre-configured. This is the interface that connects you, the router, to the backbone, this interface here. And then you have this interface, which has LAN, Ethernet 1, which would be the interface that connects with the LAN where the client is connected, which is the other device we have access to. And then there are more interfaces that we will not be using in this lab. What we are going to do now is to modify the configuration of our router according to what is stated in the guidelines for this laboratory. Guillermo and Silvia, would you like to do this part in your own router and you can show us? Or would you like me to have access? What would you like to do? Can you hear me? So you have to do the configuration according to what Nico said, which is in the tutorial. So I'm going to share my screen. You should already be in the router, as Nico had said, with the letter X, and that is the identifier corresponding to your group. Once you're inside, you have to do this part with the configuration that is missing. And this part here has the prefixes that we have to configure, both the incoming and outgoing ones, what we're going to allow, what we're not going to allow, and what has been specified in accordance with the roadmaps. So at this moment, Celia, while you do that, can you hear me? So while you do that, I'd like to clarify that if you look at the guideline for the lab, the lab guide contains the list of the roadmaps and the access lists that we're going to use. So you only have to copy and paste it the way as it is, exactly as it is in the lab list. If you scroll down in the router configuration, we add roadmaps and access lists that we'll use later on so that you can copy and paste the access list. And in the same way, you can copy and paste the configuration, the BGP configuration contained in the lab guideline, replacing X with the number of your corresponding group. You have the microphone. Back to you, Silvia. Thank you, Nico. So access global configuration mode. And there you have the prefix list and the roadmap configuration. Obviously, later on, I will be explaining this, but this will be helpful for the RPKI validation. This also has a local preference that has been assigned. And now that we have the prefixes and the prefix for the roadmaps to deny or enable, we're going to go to the BGP part in order to create the neighbors. Nico, are you going to show something of the tutorial, or shall I go straight on to the configuration? You can go directly to the configuration with the commands and explaining this line by line. So we are going to create the configuration. We have been assigned an autonomous system, as was mentioned already. In this case, I am group 5, for example. It's 65,005. That's my ID. And now I am in the BGP process and I have to assign what the instructions state. This is my ID. The last value changes, as we explained, depending on your group number. And then the neighbor, in order to create this with the router, the border router that Nico has. While Silvia does that, and you follow, the BGP process is defined as the BGP router 65,000 ending in the group number, then the router ID will be 10641 and ending in the group number you have. And then the BGP and the rest of the configuration of the IPv4, IPv6 neighbor, because we're going to have two BGP sessions. One is IPv4 and one is IPv6 session. So you can copy and paste it exactly the way it is, because this contains the prefixes and the IP addresses, which are exactly the same, because the border router is the same for all. The rest can be copied and pasted exactly the way it is in the script for the lab. So once you finish configuring the address family for IPv6, both sessions, both BGP sessions should be ready with the border router. So once Silvia finishes with the configuration, we can verify this. As you realize, in order to configure the IPv4 peer, you have to access the address family for IPv4 and unicast, and we configure all the neighbors. And then for the IPv6, you have to exit with the exit address family in order to enter the IPv6 address family. In that way, you can configure the neighbor for IPv6, as was mentioned by Nico. Silvia, could you please scroll up so that we can see the script? So scroll down, please. Yes, that's better. I can see it enormous on my screen, but anyway, all right.
No se ve.
¿Se ve por ahí o no?
No, porque lo que tenés que hacer es...
So this is one of the problems you have with Zoom when that happens. Yes, tell me. What you have to do is disconnect from the router and connect once again. Do the following, Silvia. Click, reload that site, reload that page. Just refresh. It's asking for the password again. Yes, you have to include the password again, yes. And then you have to stop sharing and then share your screen once again. That's the problem we have with the Zoom. Okay, just a minute. It takes a couple of seconds. So I'll stop sharing once again. I had done that already, but let's try again. Would you like me to try sharing my screen? So let me try and share my own screen. Can you see my screen? Can you see the topology? There we have it. So I now access the topology of Silvia's group, Silvia's router, in order to show her router. So I'm going to enter the router for the topology. I'm going to copy the password for that router. One thing while Nico looks this up, please do not enter the routers of another group. The idea is that each of you should configure your own router. Otherwise, people won't be able to do the exercise. So each of you registered, and we prepare the table so that each one of you can configure your own lab and not someone else's, because we have seen that there are some configurations in some of the routers that do not correspond. So here we are. So can you hear me and can you see my screen? So the last thing that Celia did was to configure the BGP session. This is 65005, which is her autonomous system. This is a neighbor address family configuration in IPv4 and IPv6, respectively. And here I did a show run with the router configuration. This has been configured already. Now, following the script for this practice, we visualize the status of the BGP sessions in IPv4 and in IPv6. So we put show BGP IPv4 command, unicast summary. Here we are. This is the IPv4 session with the border router, telling us that it has been set up 5 or 6 minutes ago, and apparently we are referring 56 prefixes from the border router. Click enter once or twice because we cannot see it here. Yes, it's on the screen now. Thank you. So I executed the command show BGP summary to rapidly see the IPv4 sessions that have been established. It tells me that we have a BGP session with IPv4, which is the IPv4 of the border router. This is a name. This was 6 minutes ago, and I'm receiving 56 prefixes in IPv4 coming from the border router. If we execute the same command, but now to see the IPv6 session that has been established with the IPv6 prefix for the border router, was about a 6 and a couple of seconds ago. We have received 49 IPv6 prefixes coming from the border router. We can see exactly for that neighbor which are the blocks that we are receiving, the 49 blocks which are here.
These are the 49 blockers that we received from the border router. And if you look at this, close to the end, you see that we are receiving that block that we are going to work with in the rest of the practice. That is 2803.29,008,000/34, originated in Autonomous System 64135. and press on Enter so that we may see this better. Yes, whenever I make that mistake, please let me know because I will keep on doing that. So this is the BGP table of the blocks, the list of blocks that we are receiving of the border table, router table. So specifically, this is the border that we're going to use for the rest of the, that is 28, well, etc., slash 34. And here we see that indeed it originated in Autonomous System 64135, that of Lucknow, and then 65,000, it's the Autonomous System of a border router, and then it comes to us. So this is the path, and it is correct. It is consistent with what we assume should be. So going back to with the practice, we see IPv4 and IPv6. We visualize the blocks that we receive. And what we're going to do now is to add each of our routers, we're going to add the connection. We're going to connect our router with the RPKI validator. If you look at this, the router, Sylvia's router, in this case, the process has not been configured yet. The process connecting it with the RPKI validator. It has this validated. We're going to use it later, and we're going to check what that means. But our router is not connected with the validator yet. But to do that, what we'll need is, first of all, we would need to know the IP addresses of our RPKI validator. All the groups are going to use the same RPKI validators, the same two. We're going to define two so that if one of the validators stop responding, then you'll have the other one. So let's put the two of them so that we'll have redundancy. Now, it's worth saying here, now, if this were production and if this remains later, well, if this is something that I'm doing, providing service, we said that among the two, we run the validating software, and it might be better to maintain two different validators, for instance, a forward and a routinator. So, for instance, if any time I have any problems with any of the validators, I know that I have a redundant validator, and the odds for having the two suffering the same problem is much lower than if you have the two validators exactly the same. So having diverse software also increases your resilience. In our case, the two are forwards, and you have the addresses here. Here it should say 171. 70 and 71. That's a mistake. So the RPKI command, the configuration of the router, the new configuration of the router, and I write RPKI, and there I enable the process, the RPKI process in the router, and then I have to declare this. This is the time. How often will the router bring the validation information to bring the data that the file with all the blocks had and the autonomous system that originated? How frequently will the router try to bring that information from the validator? This is in seconds, so it's going to be every 5 minutes in our case. So so it's going to be, yes, it's configured, Nico. Is it configured? Yes, I put it there in red. Okay. So then we define the two RPKI servers that we're going to use with the preference. We will name them 1 and 2. First, it's going to try to connect with this, and if it's unable to do it, if it cannot connect with this server, we'll go and look for this other one. And if this one stops responding, we'll go back to this one. So you configure these two lines in the router. I won't put them here because it's going to tell me that they are already configured. So, After you execute those two lines, we quit the config mode, and we very quickly you can go back to configuration. And here you see that at the end of configuration, you have that the RPKI process, the calling time 5 minutes, and the two RPKI validators that we'll use with the preferences. So now this router is connected to the validator. If we go back, if for instance now we execute the command to visualize, you remember that earlier today we had visualized the IPv6 blocks, for instance, that we are receiving from the border router. If now we focus specifically in one of these blocks, for instance, this one that we said that we're going to use throughout the session today, BGP, IPv6, and the block specifically. Here we see the information of that block. Sorry, we can't see anything. Can you hear? Yes, now yes. Perfect. So, as I was telling you here, what I had done is, once again, I had listed the blocks that I received from the border router, very specifically for this last block that we'll use in practice. I execute the command, and here BGP and IPv6. This block here, this /34 IPv6, originated in autonomous system. This autonomous system. Sorry, we're having trouble. Again. It's there in the room. Yes, it's here. Yes, because I can hear you perfectly well. I never lose you. Just go on. Well, that block, this is the first time in history that working remote is better than on-site. That's a funny thing about hybrid events. So the block in which we are going to work originates in 135, then 265,000, and then it gets to us. And here to 65,005, that is Sylvia's autonomous system, where we are today. And as we added the RPKI process and the router is bringing the information from the validator, it gives us that information telling us that the block is valid. What does that mean? Well, as Erika explained earlier today, this means that this block, this /34, indeed, the ROA was created with the authorization for it to originate in this autonomous system 65135. No, 005. Now, yes, let's recap. So you saw what we've been doing. We configured the topology that is here. It's a lab, but it could be a basic case of a connection of autonomous system to an IXP router, for instance. That could be one of the cases, or an autonomous system to a provider. So what we are doing now here is to configure all the RPKI and BGP. So with what you've done, then the BGP has been configured in IPv6, and the router is connected to the RPKI validator that Nico did initially. We didn't give too many details showing the configuration. As a matter of fact, there's a video that he did with Alejandro Costa that's there in the link. If you want to consider a validator and install it, you have a very detailed explanation, but we don't have details. What we see here, rather, is how to use the validator once it's installed. You configured BGP, and from now on, the router, in addition to receiving the BGP prefixes, is connected to the RPKI validator, so that it has an extra source of information to decide whether a prefix is valid or not. So I don't know whether Paul or Nico can show the ROAs that were created at LACNOG Autonomous System, the 2 ROAs I have. Yes, I can show them. I can show them there. I have them here in Milaknik. Well, I wanted to show in Ford. Don't you have them in the CCV? Oh, yes, I do have them. Right. Whatever you wish. Now you'll have to find the validator. Here is the validator. So there you are. grep AS 64135. That's it. Now enter. So it will go up a bit more. And there, what you see here is the 2 lines. What Nico is showing is what the validator, what the Ford validator generates. It downloaded the repositories and validated all the information cryptographically, and it keeps many things. The entire list, over 100,000 rows. Here we did a grep to keep only the prefixes originated by autonomous system 65135. It's only those 2. So you see, this is what Erika created earlier today, from the website of LACNIC. So what the row says is autonomous system of origin 65135, prefix length 33 to length 48, and down 64135. And the IPv6 block is a more specific block, /34, with maximum disaggregation length up to 48. So that is the row information. Now, if we look, remember that the block of the autonomous system is 64135, and you have a 33 and a 34 and a 44 length. Now, if you go back, Nico, it's that. There you have 34. Notice that you have prefix /24, and it looks as who it originates with 64135. So what does that give us? It's, well, the block is 34. The length is right. It was from 34 to 48, and the autonomous system is consistent. It matches, so the RPK validation state is valid, right? Because the origin autonomous system is 64135. The length is okay too, and that's all. That's the only thing you have to look at. RPK, I won't look at the rest. Guillermo, I did the same for the other block here, for the length 33 that you showed, and according to the Euro, it said that it should have been originated by 64135. It allows you to go to /48, and the state is also valid. And the same, that is the 2 blocks that it's generating and being published by the autonomous system 64135, for which we have a row that is valid. Well, I think that so far, I don't know whether now it's clearer. If we look at it more in practice, as a matter of fact, if you show a complete BGP show, the complete table, so that you can see how it changed and showing now a valid state.
So click enter. You will see that the V that you had initially does not appear. That showed the RPKI validity status. All the lines have a V in at the beginning, stating the RPKI validity status. If you haven't configured RPKI, this does not appear, just an asterisk. When you validate RPKI, then this appears. It's another way of viewing the same thing that we saw earlier. Guillermo, I see the IPv4 table here. This is not part of the practice, but I think that here there are some blocks that have a different status. It could be unknown or they have an invalid status, which could be the test block, which are the ones of RIPE that we included on purpose. And these are generated with an invalid ROA, so that they would look as invalid here, this IPv4 block. But just for the purpose of showing, like Guillermo was saying, the validation status depending on the information that the router brings from the validator. So you can tell us how this practice session continues. Are there any questions from the participants? Any doubts? Or shall we continue? You can call Erica. All right. So going on with the practice session. The questions that are asked and analyzing this specific prefix 2803.99.10.8000. What we're going to do now is to use one IP address of that prefix 2803.99.10.8000::1. If you go to the router and look at the information that corresponds to the IP address, it's no longer a prefix, it's an IP address. So it's going to tell me, well, that IP address is part of this prefix that I received through BGP of the /34, obviously, generated in the 64135, and because it has a ROA that was created, the status is valid. So in the script, what happens with the validation status? As Guillermo was saying, it is valid because it coincides with the ROA, it coincides with the 64135, and it is in the definition of the /33 to 48. In this case, it's a /33, and that is valid. And the prefix is 64135. I can stop sharing the screen, and you can share yours, Santiago, and you can explain the MTR. Maybe you can explain what the MTR is. I stop sharing, and you can start sharing yours.
Bueno, lo que vamos a usar ahora para ver, digamos.
So let us see the path followed by the packet and the routers. This is a command called MTR, is my trace route, and it is like a trace route, but it is more complete. When we use this, it shows us more information. That information will be continuous information for each of the interfaces of the routers that the packets go through. It works with ISMP, with trace route, but it can also be used to measure packet loss. And if you have voice over IP devices, it can also measure latency and other things. It's a very comfortable tool to visualize the information as to where the packet is going and where I wish to go. So here, you can run this in your own PC. What we are showing is the following. I'm trying to go from my notebook to a LACNIC machine called baco.lacnic.net.ui. What you will see here is lack of information. These are places where the ICMP or the trace route has been filtered and it doesn't return information. Now, the interesting thing is that we're using it in V6. So the interesting thing, as I was saying, is if you press some of the keys, you will see different information. The information here is resolving the IP addresses it is going through. If you click on the N key, you will just see the IP addresses. If I want to know what router my packet goes through, I can view it in this way. I can get the information, the IP keys. If I press N once again, I can see this display. And if you look at the right, you have packet loss, the packet sent, packets received, the last ones, which is the best one, and the average, which is similar to the ping or the ICMP, which provides that kind of information. These are some statistics. Then you have an option that is to view the autonomous systems it goes through. Santiago. Well, yes. Tell everyone that this is something that you can execute on the client. You access the client device. You can execute this one and that one too. This is in case they wish to do this, the MTR -6 barcolacnic.ui, and they will be able to see the same thing. So you can view it a bit better now, and you can see that at the end, the Baco machine is an AS28000, which is the LACNIC's autonomous system. And in between, it goes through other ASs. It is likely that some of these are the provider that provides internet during the event. Then there are some other keys. If you press Y, the Y key, you have information on those blocks that have been assigned to those IP addresses. In that case, in IPv6, if they are providers, you'll have a /32. And in the case, well, at the end of the lactic machine, it's a /48 as if it were an end user. Then it contains information on the country where these IP addresses have been delegated, the RIR, the date on which those IP addresses were delegated. Let us now go on to what Nico was saying.
Bien. No se ve. A ver, ahí va de nuevo. Ahí vine. Ahí estamos.
Ahí se ve.
So there we can see the screen. So now we are in the console of the lab. You have a console where you see the router and another one where you can see the CLI, the console of a Linux. During the lab, we're going to run an MTR to the address 2803:9910:8000:1, which is the one that Nico showed us a while ago. Can you see it now? So that would be the command that we're going to run now, and we'll continue running for the remaining of the lab so we can see how the routing changes. Did everyone copy that already? It's in the chat. So we'll keep this MTR running, and what we can see now, these leaves are group router, mine is number 4, my group is number 4, and that IP address has not been assigned to any interface. That is why we don't get to the end router. But this is where the IP address would be for the purpose of the practice. This is a minimum detail because what we are interested in is just how the tracing of that packet takes place, which has all these hops. So Sandra now has the floor. I think we're going to go over to the coffee break, and then we'll finish the session, the practice session. In the meantime, those of you who are lagging behind, please try to advance with the configuration and to try these things out. Maybe you can leave this running during the break, and we resume afterwards. So before you go to the break, I cannot see the audience. I can only see you. But it would be great. Maybe people can raise their hands to have an idea how many were able to connect, and if you're able to follow the practice. Please, a show of hands. There are quite a few. More than 15. Great. So those of you who haven't been able to get this far can ask the other people to help them out. And like Guillermo was saying, right after the break, we are going to do more interesting things. And you can then tell us what happens. See you in a while. So thank you very much. We now have a 30-minute break, and we'll continue with the final session of this tutorial.
Bien.
Hola. El que necesita ayuda nos levanta.
If anybody needs help, please just raise your hand and we'll come down. Please check the commands and pay attention to the MTR and the number of hops and also the origin. Show BGP summary and unicast, and check that part. How validation is being done, and also the path that originated that prefix.
Hola. Antes de empezar,
Before resuming, I would like to know if anyone needs any help with the tutorial. Is there anyone who could not make progress with the tutorial? So please let us know anyway if you have any issues.
Ok, te doy la palabra. Bien. ¿Está Edu por ahí? Chicho, hay que esperar a Edu y a que vengan los chicos de soporte. Para que- Y Marcio, me parece. Hola, hola.
So welcome back. We're now going to resume with the tutorials toward a more secure IP connection. Guillermo, you have the floor. So thank you, Sandra. While we wait for everyone to come back in, we're going to be asking some questions. Please tell me, have you been able to advance? Those of you who are doing the practice, the demo, have you been able to configure and with the BGP part? Raise your hands, please. Let me count. 6, 7. About 15 have managed to do so. So what we have been doing so far is to put into practice what we saw in theory. So this is to configure an external BGP session between an autonomous system and another. That could be done with our provider or with an IXP. And once the BGP has been configured, we learned the prefixes, we learn everything shown to us by the provider. We decided to do it in this way to make the lab easier, but normally you would have applied some filters. Nico, I don't know if you showed these, but otherwise please show them once again, the ones we have at the beginning that we applied in the neighbor. Can you hear me, Nico? Sorry, can you hear me? So these are the filters that we have in the neighbors of the routers for each group. For example, the router of each group, let me show you, the router of each group does not have applied filters. It allows everything, but if we look at the border router, which is lost somewhere, yes, here it is. If we look at the border router does have, in the BGP session that provides transit, it applied these route map, which permits some ASNs. So the groups, instead of receiving the entire global routing table, they received these 40-something. So we can go back to Sylvia's router. Well, here it shows that no filter was configured. And here you can see all the prefixes. All the prefixes, the 49 prefixes sent by the border router. We received this, and we have these in the BGP table. I don't recall whether you showed the RPKI commands, show RPKI connection. No, but we can do that now, RPKI. Here there are several commands that we can show you. The show RPKI, he corrects himself. Yes, show RPKI cache connection. Can you see it? Cache connection. Show RPKI cache connection shows where it is connected to group 1. 1 is a preference. Remember, we put 2 RPKI servers, one with preference 1 and one with preference 2. But we didn't define the groups of servers. They're all in the same group. So it just says connected to group 1, but it doesn't specify which. The one that has preference 1, which has this IP address. And then what we can do is to do this. Now we have to wait for a while. because what this does, without any kind of filter whatsoever, is that it shows all the entries received from the validator. So the file generated by the validator, so that whole list that went by very rapidly, there are 274,654 IPv4 prefixes and 59,406 IPv6 prefixes. So this is the entire validation table of the 5 RRRs. So this is what Massimo showed us today. And this should coincide with what the fort has in its table. 200 and something thousand prefixes. So 300,000 entries in that CSV file. So this only shows that the router is connected to the RPKI server. We saw that we are receiving the BGP updates, and each update has a validity status. All are valid, at least the IPv6 ones are valid. Nico showed us that there was some IPv4 prefix that was invalid. Does anyone have any questions? Or do you need assistance? Someone over there? Hi, good afternoon. I'm Simtao from Peru. Could you please repeat the part on how you analyze when a prefix is validated and if the origin is validated both in IPv4 and IPv6? Let me see if I understand your question. What we had done to analyze a prefix, the prefix that we're working with here, in fact, we're going to work with one IP address from a prefix. The prefix we're working with is precisely the one we have here on the screen, 2803.9910.8000/34. So if we visualize the BGP table for the IPv6 prefixes, the information regarding the prefix we're working on in the lab right now, 2803.9910.8000/34, the typical thing that any router would showing regarding the prefix is what the prefix is, what the mask is, the AS path, the one on the right, which is the autonomous system that originated it. In this case, is 64501. And then the border router, and then this router here, which is the AS path, and it's 65,005, because this is the group number 5, which was Sylvia's group. Now, because we enable the RPKI in the router, in addition to the information that it will traditionally show in the BGP table, we see this here. This is only shown when we enable RPKI. When we enable RPKI, it verifies the status of this prefix that we are doing the query on. And this shows the validation state, valid, because there's a ROA, as we saw this morning. There is a ROA that was created in the LACNIC system, in this case, that says that this prefix, 2803.9910.8000/34, is authorized to be generated by the autonomous system, 64135, sorry, until /48. So any prefix with these characteristics and from 34 to 48 originated in this autonomous system will be valid. Any prefix with identical characteristics originated in a different autonomous system other than this will be considered invalid. Nico, show him the ROA.
The ROA, in the LACNIC system, you say? No, Fort. This is the ROA that was created for that prefix in the LACNIC system. Here you have it, 2803.9910.33/48, and this is authorized And in RPKI that I have somewhere, let me see where, the RPKI, if we look at CSV file, that is the CSV that are validated, we look for the autonomous system 64135. It has two prefixes, particularly this is the one that the router is receiving to generate precisely this validation status. So you see that what Nico showed, could you show the screen again? That's what he said earlier, that the prefix is a /24 with a maximum 34 with a maximum length of 48. If you receive that prefix with a length of up to /48 and it is originated by 64135, that will be okay. Now, if it's longer than that, for instance, longer than /48, 49, 50, that will be invalid. And if it comes with another autonomous system, 2, it would also be invalid.
Cualquier especificación que se salga de esto es inválida.
Anything that moves away from this will be invalid if it's different from 64135, or a mask that is larger or smaller. Well, not larger, but larger than /48, 49, 50. That's so old-fashioned. Speaking of masks, that shows that now it's called the prefix length. Well, prefix length is confusing because this is very clear. Okay, so now Polo is going to show the MTR and he's going to explain something that they've been asking about at the break. Yes, so I give him the screen.
Colo está igual que yo, tiene tanta pantalla abierta que ya no.
Hola.
You have so many screens open too.
Había una consulta de
There was a question about, well, here
en el
we are running the MTR in the CLI that you have in the lab, and the question was, why is it that if you pressed here on this key, for instance, Z, it didn't show anything? Well, the issue is as follows. When you run MTR, you need to take information from each IP that appears there, and that information is available in a platform that is called SignRoot. That is a very interesting project where, in addition to filtering prefixes that are not valid or some prefix that is not delegated in the internet, it has information that is similar to a whois with data, with minimum data of that prefix, who it is allocated to and since when, and the length of the prefix. So this is what we saw today. And in this case, as we are using an IPv6 block that has been delegated, but that has not been announced or routed yet, we just use it here at the lab. So what you will see is that when the MTR queries the SunRoot, it won't find it. So that's why it doesn't bring any information. And in addition, as it's a local lab, it's not going to solve the name to IP address and the other way around, because these IPs are not assigned to any DNSs. If you wish to have more information about this, here there's a place that you can see, and it's asnchimera.com, and there you can check all the information with the prefixes that was delegated by LACNIC, for instance. So this same thing through the low-level MTR does the same query that you do here. Anyway, if you have any more doubts, we can discuss it later. MTR queries those IP and brings the information. In this case, at the lab, it doesn't bring any information because the block is not routed or assigned or seen by sign root. Put the MTR again to see how we see it. Okay, so there, although you don't see the autonomous system it goes through, well, you see that it's leaving out the lab. There are addresses of the internet that are not, it's not part of the lab infrastructure. So, well, that's what we can see. Unfortunately, as he said, it doesn't show the autonomous systems. That was the initial idea, to be able to identify where it went through. But you can see that even because of timing, etc., it is leaving this infrastructure. Yes, Polo? Yes, just a brief comment, because what Colo said, the MTR brings the organization. Wait a moment, Nico, because we have a problem now. What happened? What happened? What do you see on the screen? Something happens because it's no longer the trace that we were seeing. Oh, the trace changed. Yes? Does anybody know what's happening there? Are you leaving a gift for the newcomers? Well, Grace promised a gift for whoever guesses what's happening there. Well, in the meantime, let me say that at the lab, as Santiago said, the organization that provides that translation, they use with MTR of prefix to autonomous system to see what autonomous system each prefix belongs to. This is a database of Team Cameroon. Maybe the reason why they are not updated is maybe when you publish them in the global table, maybe they don't introduce them until you do that. But the prefix itself, the blocks, the autonomous systems, all the IPv6 blocks and the ROAs are routed. None of this is simulated. It's all on a real platform. This is really connected to a board. It's really receiving the internet global table through an ISP. The ROAs are created in the LACNIC platform. If you do whois of those prefixes, you'll see the autonomous system, all the information that we used here. But as Santiago said, apparently, Team Camry has not updated it in their database. Now they might do it once in a while, so it makes sense not to have the autonomous systems. But anyway, none of the autonomous systems of the intermediate blocks. Maybe it has some kind of filters to those questions in them. All this is in a cloud of a specific provider, maybe the MTR customer is conducting a query that we didn't consider. Now, the important thing is that the prefix was being routed to a certain point of the internet, and now it's changed the trace. Do you know what could have happened, Nico? Now we have somebody is saying that has an answer. Nicolas Cañar from Colombia Net. Well, apparently a router is announcing that prefix there in the local network, and that's why it changed the route. How do you know that, Nicolas? Well, I just thought about it because if it changes the route from 10 to 3, it's because somebody asked for it and it took it. Yes, exactly, Graciela. He got the prize. A kiss by Graciela. Well, somebody hijacked the route. This looks like a route hijack, right? Don't leave because at the end there's a Kahoot. So now we'll look for the person who did it, who hijacked this. Sooner or later, you will know who it was. You can follow the practice, Nico. Let's see who was the funny guy that hijacked this. Well, of course, this part is part of the practice. So the practice says, after the MTR that Santiago explained, now we wait for the trainers to make some changes. This is a very polite way of saying, now we want one of the trainers to hijack a route. So what do you see? Well, as my namesake said, wait, I'll quit sharing. Let me see whether I can share it. Can you see it now? Yes, a little larger. Could you enlarge it? The last time that somebody changed the size of the font, everything crashed. So this says, now we wait for the trainers to make some changes, observing what happens with the MTR. So one of the trainers, we are going to see who it wasn't me, hijacked a route, as Nicolas said there. So what do we see? That it changes the trace and it goes to a destination through some leaps that would be the normal thing that was happening until then. So by refreshing the MTR, then apparently after 3 leaps, 3 jumps, then the route is over. And now they put the IP address, apparently. It was assigned to some interface or something because the last jump is appearing. So let's see what's happening. So to that end, we'll now visualize again Sylvia's router. What happens with that prefix, with that IP address, 2803, that is 2803.99.10, 8000:1. This was part of this prefix, originated in 64.135 and with a valid state. Wait until they do it. Let's give them some time. Give them the command and give them time to analyze it, and then we can discuss it. Yes, I'm speaking of the previous one. Just to remind you that this prefix slash 44 came from here, 64.135, but now we run the command, and I'll do the next, and then we'll analyze this. What we are doing here is, this is a case that could be a real thing. You were doing an MTR, you saw that things were going fine, and when there's a hijack, you'll detect it through some monitoring system. It's not that you will be running the MTR precisely in that moment. But now we were, or because the best monitoring system that is that all the customers call you, telling you, complaining. So what we were looking all of a sudden changed. And now, as Nicolas said, the change is most certainly due to the fact that there was some route that changed. So now we have to analyze that problem. What happened? How do we see it? Well, the first thing that I see is that there was a change in the route, and the first thing that we need to do is to show BGP. And what do I go and look? Because Nico said 33, 44, 48. I go and see the destination. Where do I want to reach? So I put that IP 2803.99.10, 8000, colon colon slash 48. So I'm not putting a prefix, I'm putting the entire thing. Well, here's the and I put the address, and with that, I will diagnose what's going on. Who can tell us something? What is happening? What do you see? Could you give your name? I'm Victor. I'm from Guatemala, representing infinitum. And what I see when I run the command is that now the route is being announced by another autonomous system, 66002, and the route is invalid because the RPKI is saying that the state is invalid. Very good. An applause. There. Yes, two comments, Guillermo. One is, as you said, why do we put an IP address here and not with the same prefix? Well, this is a suggestion, but it's a suggestion of procedure when clearing a problem. If we suspect, as they mentioned today, that it's a route hijack, the most likely thing is that they are not hijacking a single IP address, because probably nobody allows to publish anything larger than a /48. So hijacking a route wouldn't be too effective. I hijack a prefix, but I don't know which they hijacked. It could be from /33 to /48. So what's the best way to test that? Ask to look at the BGP table for a specific address that is in one of them. So if I put this IP address, this one, then the prefix, the largest prefix containing it will appear. So in this case, when I look at what is happening with this IP address in the BGP, then I see that that entry in the BGP routing table corresponds to a /48. So this IP address is part of the prefix that I'm receiving from somewhere. Notice that here something changed. In the past, the prefix that I received was a /34. And earlier it was a /34, 34, and now I'm receiving a /48. Somebody specified a prefix more specific than /34 and 44, a /48. So for this IP address, the routing changes towards the destination that is originating this prefix. As you very well pointed out, contrary to what happened with the previous one that originated in 64135 is originating in 65002, and then it goes to the border router 65000, but it's originating in another autonomous system, as there is a ROA that says that this prefix /32 to /48, anything so should originate in 64135. As now I'm receiving it originating from that, the validation state of the RPKI is now invalid because the autonomous system is not authorized to publish this prefix. So our validation system detected the problem. The prefix now is invalid. Now the question is, if we have configured RPKI and it's detecting it's invalid, why did it let it pass? What happened? Yes, although before that you answer, so in spite of the fact that this has happened, the MTR, that is the router, my group router was detected it as invalid, but the MTR still is going to the wrong place. So what is missing here? Well, Howard from Peru, well, it should go to an ACL that only would permit the valid ones and that would be rejected by the invalid ones. Yes. Now, if we want to make it more complicated, where should that ASL be applied? With a roadmap. In the roadmap, associated with the peer BGP neighbor, with what machine? But he can't answer that because that's up to you. Well, what he said is right. Yes, everything he said is perfect. He has to configure. What we have to do is to configure the filter in the lab router, in Sylvie's router. Yes, exactly. You are moving too fast, Nico. No, we have to create a filter this here. And what I'm doing now with the filter needs to be configured in some BGP node. But before doing so, you would configure, in the practice, you configure the filter in router 5. The RPKI there. So that was configured there. So I'm in router 5. So my question is, we have to apply it somewhere. My question is, where? In the neighbor BGP, it has only one neighbor in IPv6. So in IPv6. So Silva came back. Do you want to share the screen? I give the floor to Silvia. Okay, so now I would go back to this part to apply what she said. In this case, as Nico said, we are going to enter .005. 65,005. And the address family, IPv6, unicast. And here, yes, we'll have to apply our RPKI filter. So there, what Silvia just did was to apply the filter, the RPKI filter, what we just said. In her router, she starts to apply the RPKI filter. And now, well, we can see, after applying the filter, we can see how the route is seen. So we can pull the BGP unicast. We don't see it here. Did it crash? Do you want me to show it and you comment? Well, I'm no longer sharing. Can you see it there? No. Is it cabled? Yes. Yes. It may be a bandwidth problem. Well, Nico can show it. What command do you want me to execute, Sylvia? Well, show BGP neighbor. Show IP BGP IPv6 unicast. And the prefix 2803 colon 9910 colon 8000 colon 1. Now we see it. So, what do we see there? Well, what we see now is that the validation state, it's showing it as valid. Exactly. It changed. Guille, can I say something? But you won't tell me that I'm moving too fast? Well, if you don't. What I wanted to clarify today, because sometimes this is a very simple example where I have a router, my router is connected only with one provider. So it's quite clear that I have to apply the RPKI that filters of the publications of my upstream provider, that in this case is the BGP from the router border, that's the only one we have. But reality is usually more complex than simulations. So I may have several providers, and they may all be sending you a prefix. So if I do it only with one, I apply it only with an upstream provider, then I may receive it from. So the filter always needs to be applied entering all the upstream providers, at least all of which I'm sure that I'm receiving this prefix. If I receive it everywhere, I have to apply it everywhere. It's not enough if you apply it in only one, because if not, you filter that, but you let the other ones in. So remember that we had here all IPv6 in and all IPv6 out. And now Sylvia changed and the all IPv6 that let everything in, and she applied the RPKI filter. If I have other apps with other ISPs or IXPs, then I should apply this filter in all those sessions. It was that. Okay. So there, what's clear is that now I no longer see the route with the 65,002 route. So this is the original one, 64,135. This is right. So what's happening here is that the RPKI is working. We apply it. We hadn't applied it in the roadmap, so now we are discarding the invalid routes. Nico, now if you wish, you can explain the roadmap that we never showed. Give me a second, whether I can show something here. There it is. I wanted to show this. Let me see. Here it is. If you notice, if I change the command, and what I do is I see everything that I'm receiving from the border, this is before the filters. If I looked before the filters, I continue to receive that prefix. That doesn't mean that I'm not receiving it. I continue to receive it from the border. Now the issue is that as I applied a filter, If I looked at the BGP table, what ends up being installed in the BGP table it's only the valid routes after the filter. The invalid one doesn't appear. This was just to check everything that we were saying. I have the prefix before the filter. After the filter, I no longer have it. Show the roadmap to show what the roadmaps do, because I don't think they saw that. Well, we had seen this. We applied a route map that we put the inbound. This route map, this RPKI route map, has these entries. One first entry that will match those that have a valid state and set local preference to 100. So to the local, by default local is 100. So here it raises it to 200. So if we are receiving the prefix through some other way, as we don't have a manual setting of preferences, it's going as here. It has local preference 200. It will choose the valid prefix here. Anyway, if we continue to receive the more specific prefix that was 48 from somewhere, this won't act. And the other entry it has is that it matches the not found, those that don't appear in the validation information that comes from the RPKI validation. These three prefixes, we set local preference 100 to let them in, because they are not in the validation table. They're not invalid, but they just don't appear. That is, prefixes that have no ROAS created. What we do is, in view of some identical ones that have a created ROA, we put a better local preference. So what this means is, if for a certain prefix I receive it somewhere and it is in the validation table and has a ROA, it will have a better local preference than if I'm receiving the same prefix from somewhere else with a specification that doesn't have a valid state, or that doesn't appear in the table coming from the validator. So that is that those that have a not found state, if they come in the table, we put a local preference. We allow the two, and everything that doesn't match these two entries is rejected. Specifically here, there are no specifications, but for those with an invalid state, so these will be rejected. So by applying this route map, ends up rejecting all the invalid prefixes. Perfect. So now that we rejected the invalid prefix, we're going to see, please show us the MTR. Okay. Nico, can I share there? Yes, please do. Okay, so here we have the MTR and the one that you're running, and you should see that there are no changes despite the RPKI filter. So do you understand what we've been doing so far, how we got here? Well, we saw the hijacked, we detected the autonomous system that was announcing it, that it violated the ROAs with an invalid prefix. We didn't have any activated ROAs, so even though we knew that it was invalid, we were not discarding it. So applying the route map, we discarded the route, so that route is no longer there. So why do we still go to the attacker? Why do we still end up in the router of the 65,002? system, because we can't see it. But why do you have the same number of jumps and we do hops, but we don't get to the destination what? Why is it that we apply the RPKI? If the route is no longer there, why do we go back there? Can anybody think of what's happening? And Nico, don't say what's happening. No, Guillermo. I don't know whether Ivan is present because they've already answered here. Ivan Chapero. Could you read it? I can read it. Ivan says it's valid. It's the less specific is valid, but the other one is possibly reciting the routing still with the most specific routing that is hijacked because it continues to announce it. Okay. So what he's saying is that the router that would be the upstream of our carrier or our provider is the one that's deciding, because, and here comes what Nico said today, that if you have several providers, you need to know where to apply the filters and to apply in the proper one. Here we have a single provider, so all our traffic will go to our provider. There's no other way out. If our provider has not applied RPKI, it's useless to an autonomous system to rule it out if the one upstream is not doing it, and that's the only alternative. If we had more than one provider, more than one connection, yes, because we would discard the invalid route and we would take the valid one and we would go with other provider to the valid one. But here we only have the upstream provider, and that's not applying RPKI. Is it clear? Nico, you can show the topology and we can show what we're doing. Well, this is the topology. What Guillermo was saying, our router that each group manages already has the filter. So what you do here, the router will apply it and only apply in this table the valid ones. The problem is that BGP only exchanges the prefix, that the traffic follows a different decision. So we filter the block and we send all the traffic to that block through the link where we have the valid prefix /34, not the hijacked /48. We send it to the border router. Now the border router we are connected to decides on his own, and it turns out that if the border router has not applied that filter and has a BGP session where he's receiving the hijacked block, it's going to route it toward what is originating the hijacked block. So what Guillermo said, it's not enough to apply the RPKI filter only in my router. The entire path, at least all the path to the hijacked block, needs to apply RPKI, because if there's a router that's not filtering using the RPKI entries and receives the packets with that destination, the router will route it that way, because for that router, it's not registering that /48. It's perfectly valid because he's not checking any type of validation. So going to the border router, if we look in the border router, let me see whether I can see the configuration here against. So if we look at this, this is the configuration against the neighbor. The neighbor 2 that is generating this against neighbor 2, that is Guillermo's group that is generating. No, I'm not doing anything. I'm not hijacking anyone. Yes, that router that is generating the router hijack is hijacking everything that it receives here. They don't apply any filter. So what we have to do is the same thing that Silvia do it in the border router to apply what with the router that is hijacking, to filter it based on the RPKI. Wait a second, we have a question here. Hello, everyone. Let me see if I understand. That happens because the first router that applies the ASL of the RPKI does not have it in the routing table because it's not valid, but as it has default route to the border router, it will go there. And as it doesn't have the RPKI, that finds it and now goes to the AS that is hijacking it? Yes. Let's go through it quickly. Yes, the traffic that goes from the client that is running the MTR to the IP address 2803.99.10.8000 colon 1, when that traffic reaches the Silvia's router is applying a BGP filter. So she says, okay, the /48 is invalid. I filter it. So in the table, I have the /44. So I'm going to route it toward the autonomous system that is publishing the valid block, the /34, not 48. Now it turns out that I have only one that is this border router. So I route it here, that is publishing the valid block. So the packet reaches here, the MTR. So what will this router do? It says, well, I have to route it to destination. I have to route it to the more specific block in the. But this border route, as it's not validating, it has two prefixes for that destination. A prefix that is a /34 that is valid, and /48 that is more specific and it is invalid. But for this router, there are no valid or invalid because this router is not filtering based on the RPKI information. So it will route it to the most specific, to the autonomous system that originates the prefix /48. So the prefix, even if this router is filtering, as this one is not filtering, when the packet gets the border router, then it goes to the wrong autonomous system that is hijacking. So here you also have to apply the RPKI so that this router will also route the packet properly. So it has to be applied all the way, so the packet won't reach the two options, and as they're not filtering, they will send it to the invalid. I don't know whether now it's clear. Yes. So going to the border router, I just wanted to show how you see that destination. That destination is seen, it continues to be seen with an invalid state. It's still seen as part of the /48 originated through 65002, that is not the valid system. It's still seen as invalid. But this router, border router, we saw that for the autonomous system 65002, that is the one that has this peer, the 1-2, if we look at the BGP configuration against that autonomous system that is directly connected, here the information, this is a BGP session against this autonomous system, I'm allowing everything in that comes from there. So I would have to change, as Sylvia said, but now in the border route, this route map, that one that filters based on the RPKI. So it's exactly the same road map that Sylvia configured in her filter, and the invalid ones, I'm going to filter them. So what we need to do is to come into this router, the BGP process of this border router, and change this entry. Now this one, that is the one that ends with a 2, that is the peer that is hijacking the block. I have to change this. Instead of allowing everything, apply the RPKI filter. So let's configure it with the BGP router 65,000, address family IPv6 unicast, and we are going to remove this, show the MTR. Before Nico applies it, let's show the MTR, put the syntaxes, and before pressing enter, show the MTR. You can't see it, Nico. Oh, you can't press there? Well, show the MTR. Yes. Refresh it now. There you are. I didn't apply it. I haven't applied it yet. Oh, perfect. Now apply it. Just give me a few seconds and I'll apply it. Now, yes. Can you see this? Okay. Now that he applied the filter in the upstream router, the trace route again passes through these addresses that are outside. And this is already part of the internet. It's no longer part of the lab infrastructure. As a matter of fact, we can query a whois and see where it is going through. But notice that when Nico applied the filter in the router, now as the RPKI is filtered both in our autonomous system and this other one, now it discarded the invalid one, so the trace route goes the right path. Yes, if you look at this, you can see I do the same command that I used today, and I see for this specific destination, now it changed. Now it's being announced by the autonomous system 64.135. It's no longer a /48. /48 was filtered. I only see /34, and the state is valid. So both the group router, this one here, and the border router, the two of them are routing the MTR packets right, because both of them have applied a filter based on the information of the RPKI validator. Okay. And, well, so these are the conclusions. What did you saw what we did? Well, we raised an external BGP with a provider, with another autonomous system. We reached a site with MTR. We saw that we had a long path and that we were reaching destination, and all of a sudden there was a hijack. We detected the hijack through the MTR, and you see how simply you can hijack if there are no filters, if you don't have the proper configurations. With a simple command, the only thing I did was to put an IP in the loopback and to announce the prefix. And through that, I hijacked the network, and if this had been an IXP, it could have left all the IXP members out of business without being able to reach that destination. And the same applies to a provider. So it was very simple to attack like that. So to solve that, it wasn't enough to put the RPKI validation in a router and to configure it to discard the invalid ones, but the upstream provider or the IXP also had to implement it. So that is a bit the conclusion of this practice. That is, that it's not enough to configure. We have to follow all the way. Everything needs to be safe, secure. So that is important to have this validation in as many autonomous systems as possible. Guille, can I make a couple of comments that I think that are interesting, or at least it's good to clarify? Because somebody could say, well, this practice was wonderful. We all have access to the routers, creating this infrastructure to do it. But the spirit under this type of practice labs, hopefully you liked it, but even if you didn't like it, it's the same. The spirit here is to try to do things as real as possible. So here, nothing has been simulated. The fun of this lab is nothing has been simulated. These are all real routers, and the ROA information that was created in LACNIC, real blocks delegated to some organization. In this case, we used it for this type of test in LACNOG. And they use the real RPKI system, and it's an FRR. Each of you has a router connected to the border router in the lab. That in turn is connected with an ISP that Ariel Wecher is kind enough. He is our ISP. So it ends up connecting the border route of our lab with, well, it's actually several route borders of several ISPs connected in an IXP, and it's a real scenario. As a matter of fact, that border router has filters just in case somebody makes a mistake. It won't be spread in the internet. For instance, that the hijack that he did was we didn't want that to go to the internet. So that's why we didn't leave anything out. So mistakes that we may make on purpose, or maybe not on purpose at the lab, won't propagate to the real world. But the idea is to have a real scenario, not as complex as the operations of an ISP or an IXP, but yes, a real scenario, because it's difficult to simulate the entire ecosystem. It's very difficult to simulate the system of the RPKI, the creation of the ROAS and the network infrastructure with real publications. But that was just for you to have the experience and the feeling of what was going on in the lab. Good. Any other questions or comments? Ready? So we'll finish our tutorial with our last game, another Kahoot, that will have questions by all the practices that we did from the second block forward. Let's come in again to www.kahoot, and we're going to show you on the screen the ID that you have to enter to get started and to subscribe. Can you see it? So let's go in.
Nuestro tutorial de interconexión y peering más seguro, 38716. Vamos a dar un momento para que terminen de conectarse todos nuestros participantes presenciales y los participantes que tenemos remotamente.
Erika.
Señor.
Hay alguna pregunta que es de la primera parte también, o sea, está mezclado ahí, o sea, porque hay alguna pregunta conceptual y alguna cosa que vimos en el laboratorio.
¿En el Q&A del Zoom?
Sí, en este Kahoot. Sí.
Léela, Nico.
No, que hay, digo que algunas de las preguntas de Kahoot no son solo del laboratorio, sino que son conceptuales también de la primera parte.
De la teoría. Exacto. Listo.
Claro.
Vamos a tener entonces todos los temas que hemos visto desde el inicio del tutorial.
Y hay alguna pregunta engañosa también, así que piensen. Puede haber alguna con saña, con un poquito de saña nomás, para que sea más complicado.
Eso, Nico. Como
Estamos bien
nos
de tiempo,
gusta.
¿no?
Tú sabes cómo nos gusta.
Creo que
Las
es la primera vez
preguntas.
en la historia que estamos terminando 20 minutos antes de la hora, ¿no?
Sí, sí, sí. Muy bien te comportaste, Nico.
¿Viste? ¿Viste, Guillermo, que no, hoy no hablé tanto?
Bueno, último minuto para que terminen de conectarse al juego y damos inicio. Creo que no se han sumado más. Tenemos 50 participantes. Iniciemos, Nico.
¿Iniciamos?
50.
¿Sí?
Ah, están.
Una, a las 2 y a las 3.
Inicia.
¿Cuál es la primera?
Sí. Bueno, vamos a iniciar. Tienen un tiempo para responder. RPKI provee autenticación de origen de los prefijos IP publicados por BGP, encriptación BGP punto a punto, seguridad en el camino BGP completo, lo mismo que el juiz, pero autenticado. 6 minutos para responder. 6 segundos, perdón. 3, 2, 1. Bien, bien, creo que estamos entregando la información bien, quedó claro. Efectivamente, RPKI lo que nos permite es autenticar el origen de nuestros prefijos publicados, ¿no? Vamos a indicar por qué sistema autónomo estamos publicando todas nuestras rutas en nuestro BGP y los diferentes peer que tenemos con nuestros neighbor. Dale, Nico, segunda, vas tú. Bueno, vamos a ver aquí el marcador. Tenemos en primer lugar a Raúl Alejandro, luego Nicolás. Nico, ¿te inscribiste en el juego?
No. Sería, sí. No, podría hacerlo para divertirme porque total estoy como a unos cuantos kilómetros de ahí como para que me vengan a buscar, pero no.
Cap,
no soy yo.
En tercer lugar. Vamos con la segunda pregunta, vas tú, Nico.
Ahí está. La segunda dice, Manners es, ¿qué es Manners? Un sistema de encriptación resistente a computadores cuánticos, seguridad en el camino BGP, conjunto de recomendaciones para que los operadores protejan sus redes o un registro ordenado de todas las direcciones IP delegadas a un operador.
5 segundos para responder.
Ahí está. La respuesta correcta es, Manners es un conjunto de recomendaciones para que los operadores protejan sus redes. Seguridad, buenas prácticas, recomendaciones y buenas prácticas. Las posiciones hasta ahora cambiaron un poco. Nicolás, con ese anagrama ahí, está en primer lugar. Cajb está en segundo lugar. Y Andrés M pasó al tercer lugar. Y Chapulín ahí, que viene del anterior, viene repuntando ahí. Te toca, Erika.
Un secuestro de ruta es publicar mis bloques IP delegados desde un ASN que no es mío, publicar un prefijo IP originándolo en un ASN no autorizado para ello, secuestrar al operador de un ISP para que no pueda operar su red, un tipo de ataque al DNS.
Esta admito que tenía un poco de trampa.
Bueno, bien, los que respondieron secuestrar al operador de un ISP para que no pueda operar su red. Efectivamente, pues es publicar este prefijo IP desde otro sistema autónomo que no está autorizado para hacerlo. Muy bien, Nico, dale.
Exacto.
Cambió. Tenemos a Andrés M en primer lugar, Rambo segundo lugar y Cap tercer lugar.
Esa sos vos, Erika, que venís ahí en...
Tengo a mi hermana.
Fort es, ¿qué es Fort? Un software para la obligación RPKI, un servidor recursivo DNS, el número 4 en inglés o un modelo de auto. Bueno, el número 4 en inglés, fantástico los que pusieron esa respuesta. Efectivamente, Fort es un software para validación RPKI, como dijo Erika, como mencionó hoy en la mañana, hay otros Routinator y otros tantos más software para realizar validación RPKI. Vamos a ver cómo están las posiciones. Rambo, este es como el resurgimiento de Rambo, es como Rambo 19, no sé cuántos van de Rambo. Rambo está en primer lugar, Andrés M en segundo lugar y Cam en tercer lugar.
Continúa en tercer lugar.
La última pregunta es tuya.
Hoy es el cumpleaños de Guillermo Sicileo. Guillermo ya no cumple más años. Nadie conoce con certeza la edad de Guillermo. ¿Correcto o todas las anteriores? 5 segundos. Correcto, muy bien.
Exacto. No es todas las anteriores porque si bien Guillermo, aunque Guillermo no lo quiera, hay algunos pocos privilegiados que conocen la edad de Guillermo. Yo no estoy entre esos. Y bueno, que Guillermo ya no cumpla más años es algo que Guillermo seguramente quiere, pero no, Chicho, vas a seguir cumpliendo.
Listo, vamos a ver el ranking, Nico.
Pero hoy es el cumpleaños de Chicho.
Y en nuestro podio tenemos de tercer lugar, Andrés M. Idrus aparece en segundo lugar y en primer lugar vamos a ver nuestro ganador, Cap. Muy bien.
Bueno, como hoy, si el ganador está ahí entre las personas, se puede acercar adelante y
ganador,
mostrar
por favor, para recibir su premio. Y los otros ganadores que tenemos conectados de manera remota, por favor, que envíen un correo a comunicaciones@lacnic.net indicando sus datos para el screenshot. Tomen el screenshot del podio, por favor. Y felicitaciones, ingeniero, muy bien. El screenshot, por favor, del podio lo envían a comunicaciones@lacnic.net con sus datos para hacerles llegar el obsequio. Muchas gracias a todos por presenciar nuestro tutorial de interconexión y PIRIN más seguros.
Y bueno, muchas gracias por acompañarnos hasta esta hora. Ahora están todos, seguro que van todos ya derecho, están pensando en el cóctel de bienvenida. Yo me voy a tomar un café o algo, una Coca-Cola acá, en su honor.
La dejamos a Sandra para el cierre.
Gracias. Hola, hola, a ver si me escuchan. Bien, muchas gracias. Hemos llegado.
Thank you. This is the end of the day. We want to thank the trainers for all the dedication and the knowledge shared, and also the participants that have been with us all this first day. I hope that you have enjoyed again the in-person event. Tomorrow it's going to be a very active day. We're going to have the opening with Jorge Iván Espina Gomez and Alejandro Guzman representing LACNIC, and we'll also have a panel on the 4 technical dimensions of the Internet. And the first part of the presentation